now. Thank you. Okay, now I'm recording. So your discussion group posts due Wednesday, the responses due Sunday. You have a new web work that's up. You can do some of the problems after today. You'll be able to do a few more of those problems. So discussion post. Is due Wednesday. Your web work is still due Sunday. And don't forget to post your class notes after class today. Lastly, this week we're gonna have our first group work session, and it's really gonna start something that's really gonna be happening approximately once per week until the end of the semester. So our first group work is going to happen this Thursday. You'll come to class as normal, and I'll separate you guys into breakout rooms with your groups, and you will work on problems. So this week, your class participation grade will be made up of the class notes, as well as this group work that's going to happen on Thursday. So the grade for your group work goes to class participation, meaning that you must be in class to get a grade for it. If you are not in class for it, then you will receive a 0, part of class participation grade. You guys gave me some feedback last time about how the groups went, but because you guys didn't do math together, I've decided I'm gonna leave the groups exactly the same for this time. And then at the end of that group work, there's a question just asking what you think of your group that you will do by yourself. And I'm gonna use your answer to that question to kind of start refining the groups a little bit more. During the group work, the first 40 minutes of that group work, I'm going to take to have one-on-one meetings with you guys. So you guys will be working with your group, but I'll take you away one at a time and just kind of have a quick 5-minute meeting to see how things are going and to ask you questions about the class and things like that. In order to receive a group work grade, you do need to respond to that. Now, I'm not going to be able to get to everyone on Thursday, so I'll probably get to a little over half the class Thursday, and the next group work, I'll get to the rest of you guys. So the first 40 minutes, I'll be having one-on-one meetings with you, and then the second half of class, I'll be available to go group to group and answer any questions that you might have about the math. Does that sound good? All right, so we have a few things to do today. You guys ready to learn some math? Yay. Okay, so we're still talking about limits. And last class we saw that a lot of times we can evaluate limits by just plugging in. If we can plug in, then we should plug in. We also saw how to evaluate limits of piecewise functions. Today, we're going to see, well, what happens if the value is not in the domain of the function? In other words, if we plug in and we get something weird. So what are some things that could happen that would be considered weird? Values that are not in the domain of the function. We saw 2 different things. Yes, so that's one with the denominator equals to 0, or the square root of a negative. Today we're really going to be focusing on what happens if division by 0 occurs. Okay, so before we do this though, we're going to have a brief factoring review. You guys remember how to factor cubic polynomials? Do you guys remember what a cubic polynomial is? We're going to pretend that that all meant yes. You all remember cubics? Okay, so we're just going to briefly do this. There are three things that we need to remember when it comes to factoring cubic polynomials. The first two are just formulas that you have to memorize. The first is what's called a difference of cubes. And a difference of cubes is when we factor something that looks like x cubed minus a cubed. And that will become x minus a times x squared plus ax plus a squared. And this is just a formula that you need to be comfortable with. We also have a sum of cubes, and a sum of cubes is what happens if we have x cubed plus a cubed. And so this will be x plus a times x squared minus ax plus a squared. Okay, so you really just have to memorize these formulas, but sometimes it's helpful to kind of have a little thing to help you memorize it. And one of the things that helps me is saying if I have x cubed minus a cubed, notice that these two formulas are basically the same thing, except that the signs change. So minus becomes minus plus, and plus becomes plus minus. So the only difference between these two formulas is those plus and minus signs. Let's do a couple examples of this. Let's say that I want to factor x cubed minus 512. So the first thing that we would want to do is think of this as a difference of cubes. So the question is, what number am I cubing here to get 512? In other words, I want to know what the cubed root of 512 is. Do you guys know how to use your calculator to get the cubed root of 512? I'm going to show you just to make sure. So what you would do is you would press 3. It's 8 for sure, but just to make sure that we can get this, we'll press 3, and then we press second, and then the y to the x button. So you'll notice it's like x root. You press the y to the x button right there, and then you'll put 512, and it tells you that it is indeed that 8. So if you have trouble using your calculator to get that, do let me know, and we can talk about it during my office hours. So this is the same thing as x cubed minus h cubed. So my a in this case is that 8. So then this becomes x minus 8 because it's x cubed minus 8 cubed, then x squared plus 8x plus 64, where that 64 is equal to 8 squared. Is this bringing back memories? No? Does it make sense though? Is this a formula that you can use? So let's try this then. Let's say that I were to have x cubed plus 343. So now what's the cubed root of 343? 7, you got it. So this is going to be x cubed plus 7 cubed. And now instead of having x minus 7, I'll have x plus 7 times x squared plus 7x plus 49, because 49 is 7 squared. Okay, are there any questions about the difference of cubes or the sum of cubes? Good. Now, another way that we can factor by grouping, another way we can factor cubics is by grouping. And factoring by grouping is going to be used when you have something of the form ax cubed plus bx squared plus cx plus d. And so this is 4 terms. So it needs to have those 4 things for this factoring by grouping to work. And how factoring by grouping works, I'm sure when I explain this, it'll come back to you, is you separate the things into 2 groups and you find the greatest common factor of each group. So an example of this would be 2x cubed plus 6x squared plus 5x plus 15. So what we're going to do here is separate this into 2 groups and look for the greatest common factor of each group. Now, I remind you, a greatest common factor is something that occurs in all of the terms. So here I have 2x cubed plus 6x squared. You got it. So this first one, it's going to have 2, but it's also going to have x squared. So my greatest common factor over here is 2x squared. I see that 2 and 6, 2 occurs in both of them. Both have an x, the smallest being x squared. And then over here, we have a 5. So then I factor those out. So I have 2x squared, and I ask myself, 2x cubed, when I take 2x squared away, what's left over?
X.
X. Plus 6x squared. When I take 2x squared away, what's left over?
3.
3 is left over, you got it. So I have times x plus 3 plus, now I factor the 5 out. What's left over in parentheses after the 5?
X plus 3.
X plus 3. Now you'll notice that that x plus 3 ended up showing up in both places. So I can factor that x plus 3 out now and have 2x squared plus 5 left over. Now that we have done this, do you guys remember this? Yeah? Good. Okay. So that becomes x plus 3 times 2x squared plus 5. What if I were to have x cubed minus 7x squared minus 2x plus 14? Again, I'm going to separate that into 2 groups. I have my 4 terms here. What's the greatest common factor of my first group?
X squared.
X squared, you got it. And of my second group? Good job, Reno. So it's going to be a minus 2. I have a 2 in both terms. I'm going to factor out that minus 2. So when I factor out x squared, what am I going to have left on the inside?
X minus 7.
X minus 7. And then if I factor out minus 2, do I also have x minus 7 left over? Yes. Look, that x minus 7 showed up both times. So this becomes x minus 7 times x squared minus 2. Okay, do we need to do another one, or are you guys kind of comfortable, familiar with this? Yes. Say yes if you want another one, say no if you're fine to move on. Okay, awesome. Okay, so now we're gonna, this is basically all we really need to know about factoring cubics. We're gonna talk about factoring quadratics now for just a second, because we're gonna learn a new method for factoring quadratics than what you guys have already learned. So remember, a cubic is when the highest power is 3. A quadratic is when the highest power of 2 is 2. So here we have the same type of thing. I can have a difference of squares. And a difference of squares would be x squared minus a squared. And that becomes x minus a times x plus a. Hopefully that you guys are pretty comfortable with. And then we have a sum of squares. And my sum of squares would be x squared plus a squared. And it turns out my sum of squares cannot be factored. This is as basic as we can get it. We can't go further than this. So a sum of squares can never be factored. So those are basically just two things that you hopefully are already comfortable with. We're going to briefly remind ourselves of product sum factoring with just one example, and then we're going to see how we can make our lives easier if we already know what a factor is. Actually, let's do this. So here, just to kind of remind you guys, hopefully you all remember how to do this, but to factor this type of polynomial, we want two numbers that multiply to give 42 and add to give negative 13. So that's going to be -7 and -6. If you're unsure, you can kind of start thinking about it, 42. So I could have -1 times -42. I could have -2 times -21. I could have -3 times -14, but none of those add together to give me -13, which is why I end up at -6 and -7. -6 times -7 gives me +42, but they add together to be -13. So when I factor this, I end up with x minus 6 times x minus 7. So do you guys remember product sum factoring? Cool. Okay. So we're going to be doing a lot of product sum factoring in this class, but largely, especially in this first third of the class, we're going to be factoring when you already know a factor. And that actually makes product sum factoring quite a bit easier. So when, actually we'll call this factoring when you already know a factor. So we're going to start off with one that's really simple that we could do product sum on really easily. Okay, so let's say that I know that x plus 7 is a factor of x squared plus 18x plus 77. What that means is when I factor x squared plus 18x plus 77, I already know that I have an x plus 7 here. So then the question becomes, what values do I need to put in my other factor? So what I'm looking at here is, what do I need to multiply this x by, this x right here? What do I need to multiply that x by to get x squared? Whatever that is going to go right here. So I'm saying x times question mark is equal to x squared. Well, what do I have to multiply? You got it, x. So we're going to put an x right here. So I know, like I said, we're starting with one that's simple for doing product sum, but I want us to try to get comfortable with this new way because I am going to be asking you a lot of times to factor things in this new way. So then the next question is, I don't even have to think about that 18. What does this value have to be? So right here, I have this 7. And whatever that 7, whatever value is right here is going to be multiplied by 7. And that needs to give me a 77. So that value has to be 11. So now I'm saying 7 times question mark equals 77. Well, that has to be a positive 11. Notice, I didn't even have to think about the 18 when I was using this method. All I had to do was figure out, what do I have to multiply 7 by to get 11? So let's do this again with something that's maybe a little bit more complicated. So here I'm told that 2x plus 1 is a factor of 14x squared plus 11x plus 2. So this might be a little more challenging for doing product sum, but I already know that 2x plus 1 is a factor. So I just have to figure out, what is the other factor? So my question is, what do I have to multiply 2x by to get 14x squared? 7x, you got it, Ron. So that means I'm gonna have a 7x right here. And then my question is, what do I have to multiply 1 by to get 2? And what's the answer? 2. So then this becomes 7x plus 2, and that's my answer. So notice I was able to factor this without even thinking about that 11 in the middle. However, if I expand, the 11 will work out. Are there any questions about what I'm doing here? Okay, so another way that we could ask this question is by saying something like, x equals to negative 1/3 is a root of 9x squared minus 3x minus 2. What it means to be a root, do you guys know what it means to be a root? It means that when I plug in negative 1/3, I should get 0. But this is just another way of saying that x plus 1/3 is a factor. If I plug in negative 1/3 to x plus 1/3, do I get 0? I do. And plugging it into 9x squared minus 3x minus 2 also gives me 0. So telling you that negative 1/3 is a root means that x plus 1/3 is a factor. Does that make sense? Good. So now what that means is factoring this way is going to give me a different answer than if I did it product sum, but that answer will represent the same thing. It's just going to look a little different. So this is telling me that x plus 1/3 is a factor. And so now I'm asking myself, x times what is equal to 9x squared? What's the answer? (9x). You got it. So those 9x's go together. And then I'm saying 1/3 times what is equal to negative 2? What's the answer? How can I solve for that question mark? You got it. It's negative 6. So this is not 9x plus, it's actually going to be 9x minus 6. And that's my answer. How you guys feeling about this? Do we need to do another one, or can we move on back to limity stuff? Can this conclude our factoring review? Awesome. Okay. So now we're going to go back to limits. And we're going to go back to what we were talking about in the beginning, where we said last class we learned that we can just plug in if plugging in makes sense. But what happens if plugging in doesn't make sense? If, for example, we get division by 0. And honestly, the answer is that that depends on how that division by 0 shows up. So we're going to start by looking at what happens if when that 0 shows up in the denominator, it also shows up in the numerator. And we're going to talk about something that's really similar to what you guys did on your day 1 worksheet, what I had you think about then, where I think there were like 2 people in the class that got it right. So let's say that I have the function f of x is equal to x times x minus 2 over x minus 2. Actually, we'll say are there any values that are not in the domain of f?
2.
2. X equals 2 is not in the domain of f. Why? Because it causes division by 0. Are there any values that are not in the domain of g of x? Nope. Even 0 is in the domain because when I plug in 0, I don't get division by 0, I just get 0 itself. So 0 is good. I don't get anything weird. I just get 0. So here in g of x, there are no numbers not in the domain of g of x. So are f of x and g of x the same function? Are they? What do you guys think? But we just said that 2 is not in the domain of f of x, but it is in the domain of g of x. So do these two functions have the same domain? So can they be the same function? No. So the answer here is no, because 2 is in the domain of g of x, but it is not in the domain of f of x. Let's draw pictures of these things. G of x is pretty straightforward. You guys all know what the graph of g of x looks like, right? Actually, I know that you don't because I saw your day 1 worksheets. X is just a straight diagonal line. When x is 0, x is 0. When x is 1, x is 1. So when x is 2, if I plug in 2, I get 2. So I have that point right there. The only difference between f of x and g of x, we can see that if I cross out the x minus 2's, I end up in the same place. So this is my g of x. The only difference between the two functions is the fact that 2 is not in the domain of f of x. So what does f of x have that g of x does not? When we look at these two graphs, let's use terminology that we used last week. What's the difference? What's going on with f of x? What did I draw right there? There's a discontinuity, and it's a removable discontinuity. So you'll notice that the only difference between f of x and g of x is that f of x has a removable discontinuity and g of x has filled in that removable discontinuity. In other words, it has removed the removable discontinuity. Okay, Penn, you can do this. So f of x and g of x are the same everywhere except at x equals 2. Oh, Skylar. You should come to my office hours and we will talk about them because that's what we did like all last week. So I don't really think that now is not the best time for me to explain what a discontinuity is, but please come to my office hours and we can talk about it. But I guess the simplest way is to remind you that a discontinuity is when you have to pick up your pen when you're drawing the graph. Okay, so what happens then if I ask you for the limit as x approaches 2 of f of x? Using the graph, what's the answer? We're looking for limits. Remember, our limits are our expectations, so we're looking at the left and we're looking at the right. Is 2. That limit is equal to 2. Based on our left side and our right side, we would expect for 2 to happen. What is the reality? The reality is that nothing happens. Whereas if I were to look at the limit as x approaches 2 of x, what do I get? I also get 2. But what about g of 2? 2. You got it. Okay. What happens when I plug in 2 over here? I get 0 over 0. When I plug in 2 over here, I get 2. So this 0 over 0 that shows up, we saw that when we did the limit, we actually got that the value was 2. So 0 over 0 is what's called an indeterminate form. And what it means to be an indeterminate form is that it can take on any value in the world. I like to think of it as something that just hides the actual value. The 0 over 0 is just hiding whatever value it actually takes. So the question that we're going to start answering today is, how can I evaluate limits if when I plug in they give 0 over 0 and 0 over 0 can mean anything? And the answer is that there are actually lots of different ways depending on how the limit shows up. So we're going to start off with the first technique, which is factor and cancel. Okay, so if I go back up and I look at the limit as x approaches 2 of x times x minus 2 over x minus 2, I plugged in and I got 0 over 0. But what if I had canceled out those x minus 2s and then plugged in? What would I have gotten? I would have gotten 2, right? So canceling out those x minus 2s is like removing the removable discontinuity. So we're going to factor and cancel. And basically what that means is factor and then cancel out things. Exactly what it sounds like. So we're going to do a few examples of this. We'll start off with the limit as x approaches 2 of x squared minus x minus 2 over x squared plus 5x plus 6. And the first thing that we should do when evaluating any limit ever whatsoever is plug in. And what happens when I plug in here? I plug in 2, what do I get? I'm sorry, that's a minus 5x, my bad. Sorry about that. I get a 0 on top. What do I get in the denominator? You got it. So I end up with 0 divided by 0. So that's what we called our indeterminate form, which means it's hiding some value. So anytime we plug in and we get 0 over 0, that means we should do something else. Plugging in 2 gave me 0. What that means is two is a root of both polynomials. What that means is, I'll remind you, we said this a second ago, x minus 2 is a factor. So before I have even started this problem, I've recognized that x minus 2 is going to be a factor of the top and the bottom. But more than that, it's the factor causing 0 that I need to get rid of. Oops. So I'm going to rewrite this thing, limit as x approaches 2. And I know that there is a factor of x minus 2 on the top and a factor of x minus 2 on the bottom. If I already know a factor, can we use the new technique that we just learned for factoring? So we're trying to say x times what equals x squared? What's that first term have to be? Negative 2 times what equals negative 2? Got it. So this will be x plus 1. X times x equals x squared. Negative 2 times negative 3 is equal to positive 6. Knowing the factor can help me factor. Well, now I can cancel out those x minus 2s. And when I do that, what I have left is this. And when I plug in, I get 3 over negative 1, which is negative 3 for my final answer. So that was a lot of talking to get us here. Are there any questions? Is 2 in the domain of that function? No. So what is that negative 3 telling us? That negative 3 is telling us that at 2, this function is getting closer to negative 3. It's telling me that I would expect for negative 3 to happen. In other words, it's telling me there is a removable discontinuity at 2, negative 3. All right, next problem. The limit as x approaches negative 3, 4x squared plus 11x minus 3 over 3x plus 9. What happens when you plug in? Lovely, because I hate negatives and they hate me. Emil, that is why. Thank you. It should be at -3 and not 3. My bad. Sorry about that. Thank you, Emil. Okay, what happens when we plug in here? Come on, guys. I'm asking you guys the easy question here. I plug in -3. What do I get?
0 over 0.
Thank you, Kenzo. So we get a 0 over 0 here. We get a 0 over 0 here. 0 over 0 is an indeterminate form, which means it's hiding some value, which means we do something else. And so I'm going to write that as like a DSE if my pen will start working. Come on, pen. DSE. Okay. What factor do I therefore know I have? Plugging in -3 gave me 0, so I'm going to be looking for a factor. It's going to be x plus 3. You got it. X plus 3, that's the thing I want to cancel out. So I'm going to like persevere until I can find it. Well, I know that on the top, I have that quadratic polynomial where I can use my new technique. So I have x plus 3. What do I need to multiply x by to get 4x squared? 4x. What do I need to multiply 3 by to get -3 minus 1? How am I going to factor the bottom? How do I factor that 3x plus 9? I'm looking for x plus 3. What can I do to get x plus 3 from 3x plus 9?
We factorize 3.
Just factor out the 3. We have a GCF of 3 here, so I factor it out. And I end up with x plus 3. And now check it out. I found my x plus 3's. Goodbye, goodbye. And then this becomes the limit as x approaches -3 of 4x minus 1 over 3. And I get -13 over 3. Okay, so here plugging in again, assuming I wrote this down right, is going to give me 0 over 0, which tells me to do something else. What's the factor I know I have here? I plugged in 1/2, I got 0, so I'm going to have a factor of what? X minus 1/2, you got it, good job. So I'm going to have that factor of x minus 1/2. I can use that in the numerator to help me find my other factor. So take a second and let me know what the other factor is going to be in the numerator. When you get it, let me know. Actually, I'm gonna run get some water while you guys get it. And when I come back, if you want to say it privately, you can, but let me know what you get. All right. Well, we have 2 people. Good job, 2. 6x plus 4. Do you guys see that, or do I need to talk about it a little bit? Good. Can I use this same technique on the denominator? Okay, so here we got 6x plus 4 because I'm like, what do I have to multiply x by to get 6x squared? So here, this was like x times question mark is equal to 6x squared. The 4, I'm saying negative 1/2 times what is equal to negative 2. So to solve for question mark, I'll end up with negative 4 if I just multiply that positive 4 if I just multiply that negative 2 over, right? So each time I'm just asking like, what value, oops, that's the wrong color, am I gonna get when I multiply those things together? So I'm just looking at the first term and the last term there. Can I use, does that make sense, Skylar? Okay, can I use the same thing on the denominator? How am I gonna find the x minus 1/2 in the denominator? So I have actually 2 options here. I could do the GCF, but could I also think of this as being plus 0? Yeah, so then I have my x minus 1/2. What's the other thing gonna have to be? I'm saying x times what is giving me that 4x squared? 4x. But now the next question is negative 1/2 times what is equal to 0? Well, what's the answer? 0. So it's just 4x. Kind of like there's a hidden plus 0 up in there. And now I can do this in green so that it makes sense. Cancel out those x minus 1/2s. We get 6x plus 4 divided by 4x. For a final answer of 7/2. Okay, are there any questions about this one? Let's do one more when we have to use our new factoring technique, and then we're going to do a couple that involve cubics to use some of the cubic stuff that we reminded ourselves of. So I'm going to get you guys started with this one. For sure, when we plug in, we get 0 over 0. You should actually always double check, plug in. What's the factor I therefore know I'm looking for? What factor am I looking for? I got x plus 2, you got it. Okay. So I want to give you guys about a minute, so at 38, you can tell me either privately or not privately, factor the top and the bottom and tell me what you get. How am I going to rewrite this thing with the new factors? So I'm going to have x plus 2 in the top and the bottom. Tell me what the other factor will be for each one. Yes, that's a 9. 9x squared plus 19x plus 2. We have one answer. I'm just going to wait for a few more. Make sure that you can actually do yourselves what we're learning today. All right, we're at 2 answers. All right, guys, come on. You can tell me privately if you're embarrassed, it's fine, but tell me what you're getting or tell me that you have no clue what you're doing. Like some feedback. All right. Cool. Okay, so indeed, that is correct. So we have 5x plus 3 on top, and we have 9x plus 1 on the bottom, which means now I can cancel out those x plus 2's. And when I plug in, I get negative 10 plus 3 over negative 18 plus 1, which does indeed give me the 7 over 17 that Emil said. So good job. So let's do a few that involve cubics before we finish up today. So here, 8 cubed minus 512 gives me a 0. Negative 2 times 8 plus 16 also gives me a 0. What factor am I looking for? X minus 8, good job. I can't use the technique that I have been using because that only works when our highest power is 2. That only works on quadratic polynomials. So here on the top, I'm going to use my difference of cubes. Here, knowing that x minus 8 is a factor helps me to remember the formula because I know I've got to have x minus 8. And I know the signs change, so then this must be plus 8x plus 64. And then in the denominator, what can I do to find the x minus 8?
Factorize minus 2.
Exactly, so I'm gonna factor out here a negative 2, to end up with x minus 8, which I can then cancel out. And then I plug in again and I get 64 plus 64 plus 64 over negative 2, which gives me a negative 96. So negative 96 is my answer here. And here I just used my difference of cubes. I might also have to factor by grouping. Plugging in, I get 0 over 0. Do something else. Do something else. Do something else. What's my factor I'm looking for that I'm going to try to cancel out eventually?
X plus 2.
X plus 2. You got it. In the denominator, that's extremely useful for me because I have that quadratic polynomial. That power is 2. So what is the other factor in the denominator? Start calling on people that haven't been answering, unless someone would like to tell me the answer.
Seven X plus 3.
It's 7x plus 3. 7x plus 3. What method am I going to have to use to factor the numerator? To factor the top. What method did we review?
Grouping.
Grouping. I'm going to go down here and do it on the side. So I have x cubed plus 2x squared plus 2x plus 4. What's my greatest common factor of my first part?
X squared.
And on my second part?
2.
You got it. So then we'll end up with x squared times x plus 2 plus 2 times x plus 2, which gives me x plus 2 times x squared plus 2. So we just used the factoring by grouping method that we remembered earlier. We can cancel out those x plus 2s. We plug in. To get negative 6 over 11. And we're going to do one more, and that'll be our last one with this method. And then next class, we are going to learn a second method for dealing with 0 over 0 when the limits look a little bit different. So our last one here, just to kind of make sure that we're paying attention, I have the limit as x approaches 2, x cubed plus x squared minus 6x over x squared minus 2x. Do I get 0 over 0 when I plug in? Yes. So what's my factor?
X minus 2.
X minus 2. Can I do factoring by grouping in the numerator? No, we said we had to have 4 terms and we only have 3. So we should start with the GCF. What's the GCF of the top? What's my GCF up top? Something that shows up in all 3 terms. X. So then I have x squared plus x minus 6 left over. In the bottom, it's also x. Can I cancel out those x's? Do I have a factor of x on top and bottom? I do. But are those x's the thing that I am looking to cancel out? They are not. So it actually doesn't matter if I cancel them out or not. I would recommend, if you are 100% comfortable with algebra and you've always been really good at this type of stuff, go ahead and cancel out. If, however, you're nervous and you're not that great at algebra, wait until you get to the x minus 2. The only thing I have to cancel out is x minus 2. I don't have x minus 2 to cancel out yet, so I might as well just keep going. Okay, so with that said, I don't have the x minus 2 on top yet, but now I have that quadratic polynomial that allows me to easily factor it. What's the other factor going to have to be? I know there's an x minus 2. What's the other one? You got it, x plus 3. Now I can see the x minus 2's. Now I can cancel them out. Again, whether or not you cancel out those x's, up to you. If you don't, then when you plug in, you'll have 2 times 5 over 2, which is just equal to 5. Final answer, we're done.